Okay, welcome. This is day one of the software engineering weekend class. Class 1, day 1. So you're getting right from the beginning. Thank you all for coming. What do we have today? We have to go over the syllabus, the class, the assignments, what's expected of you. And I'm going to give you about 4 or 5 lectures. We're going to have a long day. It won't be that long. We're going to break every hour-ish. To give you time to, check your phone and go to the bathroom, stuff like that. Also, if anyone wants to break earlier than my planned breaks, let me know. We'll take like an hour lunch to have lunch, hopefully, if you're local or whatever. There's food around here. Actually, you have to walk out to El Camino, or what is that? I don't know, that street out there. Okay, so I am Barbara Hecker, and you are hopefully in software engineering too. Hopefully. Okay, good. That's so far so good then. And this is a continuation of Software Engineering 1. Some of you may have received an email message from the TAs that went out, and they sent the email for Software Engineering 1. They sent the wrong email on the wrong assignments. There's no project for this class. It's a totally different class than Software Engineering 1. Hello. And so what I want to do is kind of like tell you what this class is about. It's a continuation. So in Software Engineering 1, we did a software project. We went through all the stages, system development lifecycle. We looked at lifecycle models. We looked at the engineering process. And we looked at things that qualities that go into good software development. This class takes it a bit further. So we stopped at that point. And now we continue with reliability engineering, fault tolerance issues, copyright, patent stuff, a bunch of miscellaneous, I wouldn't call them miscellaneous, but a bunch of assorted topics related to software engineering, assuming you already have a software engineering 1 background. So if you haven't taken the 1 course, which some new students haven't taken, don't worry about it. It's just a different set of software engineering. So this is more of a special topics. So number 2 is more of special topics in software engineering. So it's more focused on taking it to the next level. And I'll go over a lot of the topics as well today. But the focus is going to be on quality software development and things that you can do to improve the quality of the design process. Talk about programming languages as well as methodologies. It's not a programming course, it's more of a business course. You won't have to do anything. You don't have. We shouldn't say that. You do have to do assignments, but you don't have to do anything hands-on in terms of a project. So that was the focus of Software Engineering 1. And if you haven't taken the 1, it's not a bad class to take even after this one, because that one will show you all of the steps, putting together a requirement specification, putting together a design document. It talks about testing, a test plan, and stuff like that. So it's a totally separate class, though. Not to confuse you even further. Hello. All right, so the course learning outcomes for this particular class: principles, theories, concepts, formulas, solutions, common engineering problems. The class actually does focus on problems in general rather than concepts or background information. So problems in, like, let's say the engineering process, problems in requirements, problems in testing, stuff of that nature. Using software engineering tools, we'll have a little bit more tools hands-on with the assignments, and I'll show you that in a few minutes. Demonstrating understanding of the profession, understanding of distributed. Well, we probably aren't going to hit too many distributed architecture systems, but we'll talk about different platforms in a kind of another special topics kind of class. There is no required textbook for the course. If you've looked for one, don't. There's nothing that's really going to cover this class. Problem being, as I mentioned before, it's really a special topics in software engineering class. So there's no book that's going to give you everything that you're going to need to know. But I'm going to show you a resource of a bunch of PowerPoint slides, a bunch of video lectures and things of that nature that will give you everything without having to worry about buying a book. Because most students, when you assign a book for a course, half of them don't buy it anyway, so you save your money on it, I guess, is what I'm saying. Grading, this is the part most students are primarily concerned with, the main focus of why you're here today. Figuring out how am I going to be graded for this course. As I mentioned before, forget everything you read in that email, if you read the email that went out, because we don't have a project. What we have are going to be 5 assignments, and that's on the bottom here where it says homework. Majority of the class is going to be a midterm exam and a final exam, which counts for 50%, which is kind of interesting because instead of giving you a bunch of paperwork to do, a bunch of projects, a bunch of assignments, instead what I've done is decided, well, let's just give you some exams. So a lot of it's, 50% of the score is going to be on exams. Excuse me. There will be one final exam that will be required to be taken here at the ITU campus that will require your attendance. It is, if you look at here, I don't have a category that says attendance on it. So you're not being graded on attendance. I'm glad that you guys showed up today. So if you attend the course, it's highly recommended. In fact, you'll learn more if you attend the course. However, I'm not grading you on your attendance. And I know, I understand all of you are CPT students probably, or OPT, or you're traveling, you're not from the Bay Area here. And so I get it. I understand what's going on. But I do also know that we have to enforce attendance, and it's considered mandatory at the university. However, if you do have a special circumstance in which you, and I know some students have already gotten approval for it, you have a hardship, you have a hard time traveling, I can approve it. I can approve your missing class. The only thing I can't approve is your final exam. That actually has to be taken in class. I can't do it remotely. And as we get closer to the end of the course, we'll have the TAs will send out the final exam schedule that will tell you which week, which day. And what you can do is actually arrange, if it doesn't meet with your timing, you can actually arrange a different day. So I'm kind of flexible with when you take it. The only requirement is you have to come here to take it. So it's basically enforces a mandatory attendance policy for the final exam. It'll be 25% of your class grade. If you don't take it, you can't get a grade for the course. You'll end up with an incomplete. I usually say this on day 1, and I still have students who go, "Oh, I couldn't show up." I'm like, "Well, come on, take it now." So it's can't get out of it. Midterm will be a take-home, which means you don't have to come to campus for the midterm exam. That one you can do at home, and that one will be probably not an exam. It will probably be more like a project or something, an activity that you'll have to complete. The final exam will be an exam-based, closed book, closed notes, probably short answer, which is what I like, or multiple choice kind of an exam. It's just so that I can kind of get a feel for what you've learned for the course. It's the only way I can really kind of assess, what I need to focus more on, stuff like that, for the next time I teach the course and stuff like that. The midterm exam will be a project of some sort, and you'll have 2 or 3 weeks. In fact, in the next couple weeks, we're going to be sending out an email about the midterm exam. So you'll have plenty of time to work on it. It'll be uploaded into the ITU database just like an assignment. And so it has a due date on it, and I'll talk about that in a few minutes as well. The CSLO, in the old days, we had these essays that we had to write, because most of you probably are aware that we're applying for accreditation, WASC, Western Association of Schools and Colleges, and they needed some sort of course learning objective. The CSLO essay was for that. We've incorporated it into our learning system, however, so we don't actually have to do the same essay that we did in previous terms, but some classes are still doing it. We still have to keep the item on our syllabus, so we're going to do another activity though. It'll be a writing assignment, but it won't be the traditional. If you're familiar with the CSLO essays from the past, actually just a show of hands, how many people know what I'm talking about in terms of that? Oh, none of you know. Okay, don't worry about anything from the past, because you don't have to worry about that anyway. It was really bad, actually. It was, what they used to do is they used to take these 5 or 6 of them, course learning outcomes, and you had to answer all those questions. It was really tedious. You don't have to do that anymore. And it was like a self-assessment. This is how I learned it. That's how I learned it. Now, this will be a writing assignment, but it won't be the same traditional one we've used in the past. something. And it will be a take-home. It's not really an exam. It's a CSLO. So it'll try to assess your course learning outcomes. So it'll be based upon those objectives. But it'll be an essay or something. So another writing assignment. The midterm's probably not going to be a writing assignment like a paper. It's probably going to be more of a project-oriented thing, like put together a test plan or put together a quality assurance plan or something. The homework, there's 5 of them. They're worth 5 points each. And those will be all different. And I'll go over the first one today, which won't be due, well, till the end of the course, essentially. But I'll go over that. So final exam week. The week before the final exam week, I'm going to be giving a review session to let you know what's going to be on the final exam. And the review session will give you everything you need to know, and then the TAs will give you the dates as we get closer to the end of the term. Academic dishonesty, something to mention. There's no group assignments, there's no projects, there's nothing that you would have to collaborate with your fellow classmates on. Everything's an individual assignment, everything's all individual work, which means I expect everyone to do their own work. We don't recirculate assignments. This is a brand new course, which is good, because there aren't any assignments to recirculate. Everyone will have to create their own assignments. And we're implementing different things in the system to check for plagiarism and stuff like that. So if it pops out and your assignment matches somebody else's assignment, you're not going to get any credit for it. You get a 0, and you can't return it. You can't turn it in again. There's no seconds on it. So, and it ends up hurting your grade. So you want to do your own work. The internet as well probably can be a good source. But the nature of this class, however, it doesn't lend itself well to academic dishonesty, just because of the nature of all the work of the assignments. It's really hard, to turn in somebody else's final exam, especially when you're taking it in person. The projects are going to be different as well. So, grading formula is quite standard. I don't give out A+. There's no such thing as an A+. Don't ask me for one. A is the highest grade you can get in this class, which is 100% if you actually do it, or 95 to 100%. I do give out pluses and minuses, and I'm tendency to be very generous with the grades. So, if you're grading questions, you can always ask me as well. Yes?
The grading will be like on the class basis, or it will be related or cumulative?
Oh, it's on your individual. You're not graded on. There's no curve grading.
Okay.
It's based upon your own individual work. So it doesn't really matter how many geniuses we have in this class. You're going to have the same score whether you've earned it or not. I mean, excuse me, whatever score you've earned, whether or not you're a genius or not. Whether or not anybody else in the class has gotten the same grade. Yeah, actually that's kind of funny. Good question, because some traditional colleges, it's usually at the undergraduate level, sometimes at the master's though, sometimes graduate level, they take the whole class and they curve it, which isn't really fair, I think, especially if you're like an MBA student taking an engineering class for the first time, or you're an MBA, or the opposite or something like that. You might not know the material as well as someone who already has a degree in the subject matter. And the interesting thing here is that at ITU is that we've got all kind of ranges of people. We have people that have master's degrees in software engineering from other countries, or even from here sometimes. And then we have people who don't have, who are healthcare management, or who are something totally completely different. And I encourage cross-enrollment. I encourage people with, MBA backgrounds to take this class, and people with healthcare backgrounds to take this class. In fact, that's what our engineering management program is all about. That is kind of a cross between business and engineering, and you kind of mix and match, and you kind of pick and choose which classes you want to take. And as long as you do half and half, and at the end you put it all together, you got engineering management as your degree. It's really a combo, but how can you really be good at both? You probably come in with a background on one side or the other, and you're taking classes in an area that you don't really have a background in, which is nice because you might learn something actually. And also feel free to ask me questions like this person did, because I don't know, I have a tendency not to stop and ask for questions because nobody ever puts their hands up. So stop me if you have a question. I can answer a question for you. Let's take a look at the schedule and the assignment due dates. All right, so none of the assignments are due until the very last day of the class, which is great for you guys because nothing is counted late. And why is this? Well, interesting thing. I have 2 course management systems. I have my own, and then I have the one for ITU. My own gives you the materials, ITU allows you to submit the materials. So you upload into that system. And the system's not quite ready yet. In fact, they're still building the system. We have some students who joined today. We have some students who are going to be joining probably in another month, maybe. The enrollment's kind of funny. So people kind of come in and they kind of join halfway through the course, at the beginning of the course. They missed the first session, they got to the second session, or vice versa. So it's really hard to keep track of everybody that way. So what I've done is I've set the due dates for everything as the very last day of the class, which is going to be, you know, again, like probably well, it's our last interactive session, and I'll take a look at that in a few minutes. The last weekend class schedule is the last day, is when all of the assignments are due. But I wouldn't wait until the very end to do those 5 assignments, because it's going to be time consuming, and you know, everything always goes wrong, and the database always gets overwhelmed, overloaded, and runs kind of slow, and it'll be hard to upload stuff. So the earlier you get stuff in, the better. And if you follow this kind of schedule here, you'll have more synchronization with the topics and the assignments. So as an example, we are going to get through, let's see, today's interactive session will take us through week 4. Module 4, Module 5. Well, no, I'm not going to get into defect testing. Probably just, I'll talk about dependability, engineering, and reliability, which is the last lecture from the weekday class. They're up to week or Module 4. So we have assignment number 1 is really the only one you could probably work on, I would say, between now and next interactive session, or class meeting, I should say. They used to call them interactive sessions, that's why I'm calling it that. It's not really called that anymore, it's just our class meeting. So week 1 through 4 is what we're going to get through this weekend. And then we'll come back and we'll have another class meeting. We'll get through 7, we'll get through, week 5, 6, 7, 8, 9. We'll probably get through the most of the rest of it. And then in our last one, we'll take the final exam. Because what ends up happening is we have topic by topic. And so, as an example, like right now I'm doing the introduction. I'm doing week 1. And then we'll take a break, you know, in about an hour, hour and a half. And then I'll do week 2. And then I'll do week 3. So it's kind of intense to go back to back like that, which is kind of like why I like to pick and choose the important stuff out of it, give you that content, and then let you read and let you review some of the other stuff that I may not have gone over. So I might not cover everything, but I'm going to cover what I felt was the most important part. All right, so the schedule is lined up topic by topic, so if you missed the next session as an example, you can kind of see what we're going to cover from where we stopped this time, between this time and next time. And assignment number 1 is really just the only thing that really relates to it. So I'll be going over assignment number 1 before the end of today to kind of give you a feel for how things are going to run. So. And the final exam, CSLO, everything else is kind of like pushed to the end of the course. The midterm's around week 8-ish, which is around our second class meeting. So let me take a look here and show you what I'm talking about in terms of the materials. Let me see if I can get this a little bigger. Before I continue, though, are there any questions about the syllabus? For those of you who maybe have come in late or...
Though I just saw that CSLO is at the end of the semester.
Yes, you did. You saw that. In fact, it is not due. None of the assignments are due until the very end of the semester. And the final exam and the CSLO is pretty much due on the same time, same day. As a deadline. However, that's 15, right now it's not really 15 weeks away, but it's close to it. You don't want to wait until the very last day.
I mean, before the exams, can we have a demo sort of thing?
Yes, the interactive session before, our weekend session before the final exam week, and the middle one, I'll be going over what's on the final exam.
Yeah, because, thinking about the content which we need to write for the essay, it's like I'm not able to think.
Oh, the essay is a take-home. It's not an in-class exercise, so you can think all you want. You can take, in fact, you'll have 2 or 3 weeks to complete it. So you can think for 2 or 3 weeks if you want. But I seriously doubt you're going to do that. So, you'll probably think for, Actually, you know, the essay, in fact, it's not going to be on the course learning objectives. I think you walked in late. It's not going to be on the course learning objectives. It's not like we had in the past. Are you familiar with this?
No,
oh.
I'm not familiar with the past thing because this is my first class.
Oh, okay. So you don't have to worry about anything then. That's a good question because that sounds like you were familiar with it. But no, it's just going to be an essay. In fact, you'll probably have a couple different questions to pick from. And you pick the one you like. And it might be like, why is software testing something? You know, why is QA something or something? You know, I don't know. It'll be something that if you can pull from something that you know about, you can probably answer it just fine. Any other questions on the syllabus before I continue? For those people who, okay, very good. Let me show you where you can find the syllabus, because most of you are going, I didn't get a printout. No, I'm very green these days. I don't do printouts anymore. I have this, and this is the most important thing to write down today. Let me see if I can make this a little bigger here. Whoops. Well, this is interesting. Let's make the whole thing bigger. There we go. I knew there's a way of making it bigger. You don't have to put the /ITU. Actually, you can. I wrote it down over here, but it's kind of small. In fact, I think it might be bigger up there. It is bigger. In fact, it's bigger right here, too. Bhacker.com. That's the most important thing to write down. That's where you're going to find everything you need for this class. If you don't remember anything else after today, remember bhacker.com. And if you can't remember that, my last name's Hecker, my first name's Barbara, it's B. Hecker. You'll remember that part. Okay. Write that down, that's important. So let's see. Actually, I think I made this a little bigger with whatever control I was hitting before. What do you get here if you go to bhacker.com? You get some interesting stuff. You get our weekday and our weekend. I am also teaching this class during the weekday schedule. The materials are identical. So if you click on the weekend, what you're going to get is there's two weekend classes that I'm teaching. The one that you're taking right now is Software Engineering 2. You'll see the dates right there. So this is the 5th, 6th weekend. You'll see the April 2nd, 3rd, which is about a month from now. About a month. And then we have April 23rd, 24th. The final exam will be on the 23rd, 24th weekend. Probably we're running them both on Saturday and on Sunday. Because some people might be able to make it one day or the other day. And we do have a high enrollment in this class, although not everybody's going to show up for every one of the class meetings. They will show up, hopefully, for the final exam because it's a requirement if you came in late. You must show up for the final exam and take it in person. Can't be done remotely. So you'll have to show up either on the 23rd or the 24th, so make sure you're planning that into your schedule. So that's the other most important thing to remember out of today. And we'll send out an email message to confirm everything, hopefully a couple weeks before the weekend, so people have time to, 2 weeks, 3 weeks, maybe, hopefully, at that second interactive session, we'll have everything scheduled so you guys know, so you can book flights and stuff. What you're going to see in here are forums, and so in your section, which is a little bit different than the weekday section, it's just the forum. So we have class discussion and a teaching assistant forum where you can post a question. You have to actually register, sign up on the board in order to post questions, and it'll run you through, it'll prompt you through what to, all the questions you have to answer in order to get subscribed. And you don't have to have an ITU login or anything to do that. It's just outside system. You have to go into the weekday in order to see the materials for the class. I didn't duplicate anything. But actually, let me go back 1 second. This class is currently being recorded. And if we go into the weekend object-oriented design class as an example, you'll see this. This is from the first interactive session that we had for the object-oriented design class. You see all the recorded lecture stuff. So right now, let's say, for example, you have a friend who's missing today, who's in this class. After this weekend, this will be in our class as well. So you can go in. I showed you the object-oriented one because we've already had that one. We're having it right now, this one. So there's nothing in there. There's nothing that we put in there. But these are, if you click on the links, you can see everything you missed. If you missed something, or if you're a friend, well, you guys aren't missing it, but there's people that aren't here right now that are probably missing it. And this is what they're missing. So even like right now, all the syllabus stuff I just went over, that was recorded. So this will be a part of your class as soon as the weekend's over with. As soon as we have something to put in there, which is what's going to be different between the weekend and the weekday. The weekday also, however, has recordings of every one of their class sessions. So as a weekend student, or actually vice versa, you have the benefit of taking both classes at the same time if you wanted to. I mean, you can watch both lecture sets if you wanted to. Because let's say if you go into software engineering on the weekday is where you're going to find the course materials. So if you go into, here's the syllabus I just went over. If you go into the course materials link, you're going to see 5 assignments. Same assignments for you as the weekday. Weekend's the same. And then you're going to see this. You don't actually have to, the video lectures, which is what I'm going to cover essentially, you don't actually have to go over. The only advantage you might want to go over is if, let's say, you missed and you want to know about software reliability, or you want to know about software dependability or something, like topic by topic. It's the same lecture, though. It's just a repeat of what you're getting on the weekend. So it's your choice. These are shorter. These are like an hour and a half to 2 hours each. The ones you're going to get, these are like 8 hours. So the lecture recording's longer. But I do break it up into separate part 1, part 2, part 3, so you can kind of go, she said that before lunch or after lunch, and I kind of figure out what's going on. But this lecture number 1 here is not going to cover the syllabus. This started actually after the syllabus stuff started. So you're going to want to, if you missed something or a friend wants to know, well, she went over the syllabus. It's in lecture 1, so you have to look for the weekend. So, all right. These are the PowerPoints. So you'll have PowerPoints that you can download. So it's really just, in the course materials, it's the live video recordings, the assignments, the PowerPoints, because we only have 5 assignments for this class, so it's fairly simple, actually. What you'll also get in here are the teacher or the class form, so you can kind of see, and we don't have that many postings for this particular class, so we have more in the Java class, actually. Because, Java's a little bit more technical, it's a little harder, so we have people posting questions about the first assignment, questions about this, questions about that. Hopefully we might actually see that in this class as we get further down the road. So if you ever do have a question, sometimes you can go into the forums and kind of see an answer to it, sometimes. So, all right. If you're brand new to ITU, you don't know about the EMS. We also have another, so this is where you get everything. This is where you can find everything you need for the course. If you want to turn something in, you want to go to ems.itu.edu. And let me zoom in on this guy. I didn't type login, I just typed in ems.itu.edu, this part of it. You can see that. And you'll have to get a login to the EMS. There's no way of getting around that one. And the EMS, in fact, I'm going to log in as me and see what happens. It's going to look a little different. It's going to be an email address. The ITU administration has to give it to you. I know some of you don't have it yet. Don't panic. None of the assignments are due until the very last day of class. If you don't have one, it's something to work on between now and April. So you can turn stuff in. If you get in, let's see if it works. It does work. Actually, it's pretty fast today, too. If you go into, let's see. This is going to be a different view of it. Yours is going to be red instead of green, I think. And you're going to have it, but you're going to kind of see something similar to this, I think, actually. And this is software engineering one. Actually, let me do a quick search here on 2011. Spring. Let's do that. Oh, actually, there's only one option, spring. So, let's see. I'm going to try and find this. I might have to show you software engineering. And here's our section here, software engineering 2. We have a -2 next to us. If we go in here, there may not be anything in here yet. Actually, there is. It's good. Cool. It is populated. So we have we don't have assignments though in here. If you go through this, is a slightly different layout if you're not familiar with this. And I think they're making a video or a walkthrough document that you may have received by email, which is going to be a better exposure to the system. But the reason why I'm showing this is to give you sort of some insight into how you're going to submit assignments. You're going to see these boxes, and hopefully on the bottom of the boxes you're going to see assignment 1, assignment 2. And then you click on the assignment, it shows you the description, and on the bottom there should be an upload button that says upload it. So what you can do is create these in Word files. In fact, all of the assignments are in Microsoft Word, so you can just download all of the assignments and put your answers in the assignments, save them, sometime before the end of the class go into here and put them in, upload them essentially.
So we're going to see the assignments after we are done with the class?
You should be able to see these, yes. And they are currently working on the system, so making some upgrades, modifications to it. So I'm not quite sure exactly what the interface is going to look like eventually. It's a little similar to this. There should be spots where you can go through and review and look at to see what you've turned in, I would assume. So it's work in progress. So, but the class looks like it is populated, although I don't see links for the assignments in here. I see lecture 17 down here. This is weird. So it's not quite ready yet. So when you go in, don't freak out if you don't see links for everything. It will be built hopefully before the next weekend class, which is another month from now. It should be ready to go by then.
But by the time we can download those assignments from the site which you...
Oh yeah, that's ready now.
And we can do that.
Yep, that's available right now. So you can go ahead and do everything. You can finish the class tomorrow if you wanted to. But you can't turn it in officially until the system is ready for you to turn it in, is what I'm saying. Okay, any more questions on the, these are really good questions, by the way. Any questions on the ITU EMS? Any questions on the bhacker.com website? What it's used for? No? Okay. And the bhacker.com website actually uses YouTube. It might switch to a private server soon. We're not sure. But right now, you can actually go to the YouTube channel if you wanted to. And let me just show you that real quick. If you go to the channel, it is youtube.com/BJ Hecker. My middle name is Jill. And B. Hecker was taken. So I had to go BJ for Barbara Jill Hecker. So you'll see all of the videos for the class in here. In fact, let me show you a little trick. If you hit the playlist, you'll see you'll see the software engineering here. Actually, this is the software engineering 2, and you'll see all of the videos. In fact, you'll see one for the weekend after the weekend class happens. We don't have it up there yet, but we have the weekday class that's been going on, so you'll see that there. And there's other videos on there too, and you can subscribe if you want. You don't have to. Some people like it, some people don't. So you can get to the YouTube site via the bhacker.com. You can actually see the same videos. Actually, I shouldn't say that. Different videos from that camera you can see in the ITU EMS. So you get tons of video options. So if you don't like this one, you can look at that one. The only problem with that one is it takes into consideration background noise and stuff. This is actually a little clearer, the ones that I do. So I have had some students go, oh no, the videos, I can't hear them. Because they know you're looking at the wrong set. look at the other set. Because we have ones that are done live with a camera, and then we have ones that are done on my computer, and the ones done hopefully on my computer are a little higher, because it's done directly on the computer. It's a little higher. You can actually see what's on the screen. Long story short. All right, any other questions on the way the course is going to be run? So this is the boring part that we get at the beginning of every course that you ever take, you know, the course introduction. So let me talk about what I'm going to talk about today then. When we start the lecture portion, we're going to look at the business aspect of software engineering. where we're going to look at, I'm going to skip project management unless you guys want it. I skipped it for the weekday section because they're like, oh, we don't like project management, it's boring. So I skipped it. But I am going to talk about the business aspect because it's actually not a bad introduction kind of lecture. Talk about the legal aspect. That's actually kind of interesting. Talk about feasibility studies, reliability, dependability. This is what I'm going to cover actually today. So that's kind of like the layout. And I think what I'm going to do now is hit lecture 1. Because I said it will break in about 20 minutes or so. 20, 25 minutes. Something like that. Unless you guys have questions, because now here's your opportunity. Or opportunity at the break as well. So it's only 30 slides, don't panic. It's not that bad. Plug this one in. Because this is going to give you the overview essentially of the class. So this is not the business aspect of software engineering. This is the introduction. It complements my other information I just gave you about the syllabus and stuff like that in the course. Okay, so the overview in terms of all of the marketing pitch for why you want to take this course. So this is the sales pitch, but there's no selling, you're already enrolled, so it doesn't really matter. So it's just kind of the same philosophy with Software Engineering 1. We're assuming that you've got some technical proficiency, hopefully. We're assuming that you've got, some experience, maybe not. Doesn't really matter. So this course is not really a hands-on technical. In fact, that's kind of the interesting thing about software engineering. You can sign up for software engineering programs, degrees, and all you do is programming. Or all you do is like hands-on stuff. And then you can take software engineering degree and all you get is business stuff. So this is kind of a combo, but it really focuses more on the business end of software engineering, assuming you already have the background. Assuming that, you guys probably already do is what I'm thinking. But if you don't, you can still get through it. So what this course kind of focuses on is, we know all the software engineering stuff from number 1. Now, how do you turn this into money? How do you make money from this? How do you be successful at this? And what are some of the things, what are some of the topics that you probably should be familiar with from an engineering perspective, also from a business perspective, to kind of put all the pieces together. So this is kind of the capstone of software engineering, kind of, if you think about it that way. In terms of future experiences, what you're doing 1 year from now, 10 years from now, careers in computing, careers in software engineering. So there's kind of a huge focus on looking at the long term, the trends in software engineering, what's going on. Also looking at continuing technical work, continuing technical kind of background. Looking at outside of computing in general, and kind of the philosophy of how software engineering integrates with other fields. And it's really a business topic, if you actually kind of think about it in general. I mean, that's why I kind of get into costing. As kind of a side note, we're not going to hit it this weekend, but the next weekend session, I talk about how to cost out a software project. Just think about anyone can program something, right? I mean, you guys should know that by now. In fact, a lot of successful things have been developed in people's garages over a weekend or something. But those days are kind of gone, I think, actually. Nowadays, it's XYZ company going to Acme Inc. saying, I need this driver written, or I need this project done, or I need this program to interface with my scanner or something, and how much will it cost me, and how many days will it take you, and when can you deliver it, kind of thing. And then you as a software developer, great, you know how to program it. That's not the point. The problem that faces most software engineers these days is, how many days is it really going to take me, and how much is it really going to cost me? Can I actually make it? Is it really even feasible? Which is kind of the focus of this class, because we'll be talking about, in fact, we'll talk about feasibility before the end of this weekend, but next time we'll be talking about, how do you put a dollar value on what it costs to build it, and how do you put a time frame on it? So those are essentially business issues, if you think about it, but you have to have both. You sort of have to have the knowledge of what actually happens in the development process, as well as the business background to kind of make it successful. So, and you know, as you're going through it, I'm not going to read you off of every one of these slides. This is kind of like visual, visual entertainment. If you get bored from listening to me, you can read what's on the slide. Sometimes it's totally different than what I'm talking about, but I don't know. The slide is kind of out there, talking about different fields, careers outside of technical careers, superior technical positions. Because what you're looking for in terms of software engineers, you don't want to program for the rest of your life, essentially. You don't want to be a programmer, you don't want to be a tester, you don't want to be a QA engineer, hopefully. Hopefully you want to be the CEO or something like that, maybe, or you want to be the senior level developer, maybe. You get there by learning all of the software engineering 2 stuff, because everybody knows the 1, so it's the above and beyond. So senior positions, which are almost entirely technical, industry, research, university kind of stuff, would be 1 level. Mid-level, professional positions, state-of-the-art, and they also can be dead-end, actually. In fact, that's why if you have a technology background and you stay solely on the technology end, eventually your skills are outdated, because the world changes around you. Even languages change around you. If you're not constantly learning a new language, re-educating, you end up stuck in a dead-end position, which is not so good if you want to, unless you want to continuously train on new stuff. That's why a lot of technical people get into software engineering, or they get into the business aspect of it, because there's more growth in that. It's more long-term, and you get higher up the totem pole. So technical people are always kind of lower than the management level. And the management level is hard to get to unless you actually kind of work your way in some aspects. So, all right, we're looking at the connection to the client. So some of the stuff that we're actually looking at in this particular course is from a management perspective, how to bring the project team and the software development team into a little bit more connection with the client. And part of what we'll be talking about later on in the course is how to form the communication, which is really a business topic again. How to set the plan, how to set the environment. Thank you for shutting that door, actually, so that the communication, the connection exists. And a lot of it also works with the concept of the development, the quality, the project management, the marketing, which are, again, other business topics, and that work together with the customer. So running software as a business is a huge focus of this particular course, and we'll see it right from our first lecture, the business aspect of software engineering. And each one of the topics that I'm going to run through, dependability, reliability, kind of takes it from the focus of what could go wrong and how to prevent those things from going wrong in terms of the software project. So that's one of the things we'll be looking at as well. And we also we will get into this actually today, the verification, validation issues that are associated and how that plays a role in reliability and dependability. How do we verify? And what is the role of product manager, project managers, quality assurance people, testing people, stuff like that, and how that involvement works, and how to build into the plan checks for are we building the right product and are we building it the right way in terms of what it is, our focus is. And we'll look at quality assurance. In fact, some of the assignments work off of these topics as well. So this is really an overview of the course, actually. You'll have something, in fact, you'll have two. You'll have to put together a quality assurance or a test plan or something of that nature. I can't remember right now. But the quality assurance in terms of the topic, you won't get everything you'll ever wanted to know about it. You'll get, if you want that, in fact, there's a couple of QA classes that are taught here at ITU. Testing tools or something like that. QA testing tools. There's also quality assurance. In fact, there's also, I believe, a new certificate program that's happening soon. That's like 4 classes you take for QA that give you some sort of, I don't know who offers this certificate or where the certificate's coming from, but I don't think it's IT. I think it's an external source that's providing it. So we'll see.
There are certifications which ITU is providing to someone.
Oh, really? Is it from ITU or is it from a different company though? Oh, yeah, okay. That's why I don't know either. Because it's brand new. They haven't started it yet. It won't start till summer. But I mentioned it because I remembered it when I said quality assurance. Oh, yeah, that's right. IT is building something. So they should have some program coming up soon. And here, as an example, Microsoft Quality Assurance staff is as large as the development staff is. So it's really a growing area, actually, because people are now coming to realize that quality assurance is a huge issue, more so than in development, and as equally as important. So we'll look at developing tools and methodologies for creating software that is testable, maintainable for your bugs, what it means. In fact, we'll get into these topics before this weekend is over with. And the validity of software for reviews, inspections, and testing and such. We'll look at the product manager and the project manager in terms of their particular role in the development. So this is different than, let's say, what we saw in Software Engineering 1 that went through software development life cycles and the management and methodologies associated with the development efforts. Instead, we take it out and we say, well, what about the project in general? And what about, issues that are associated with that? So, in terms of careers that take responsibility for the technical work of others, how to manage other people, how to figure out if the project is on track, how to figure out how you're going to manage and develop, a team of 5 developers, a team of 4, how big should the team be, things of that nature. So a lot of the management issues that are associated with assembling the team, managing, monitoring, which is kind of really a project or a product manager, and well, not really a product, but a project manager kind of role. Looking at the flexibility in terms of how to transition from one point to another point within the team, within the development efforts, things of that nature. A lot of these slides actually kind of look at careers and things, but we're probably not going to focus too much on the profession, more so on the concepts underlying, what does the CTO supposed to do? what is the developer? What is the information or this technology officer really focused on, and how to pretty much build your career to that direction would be more of a question. And software development as a profession in general, this is kind of the summary of what we looked at before. Demands a high degree of professionalism, actually. So a lot of the topics are kind of headed in that direction. So, as a question, is software development a branch of engineering? In fact, actually, that's kind of a controversy that's been going on for years in the States, is whether or not it's really should be called software engineering, or is it software development? Because, engineering, they have standards and they have compliance, and there's a whole methodology to the engineering background. The software doesn't necessarily fall directly or identically into that kind of mold or that model. But it does actually. There's parts of it that does and parts of it doesn't. It doesn't, but anyway, they'll be going on for more years because they'll never decide whether or not it's really an engineering science or not. But we'll take a look at that towards the end of the course, actually, in terms of what is engineering and how to build that into the software concept, because it's not always there 100%. So, by definition, the profession of engineering is creating cost-effective solutions. So solutions to problems, perhaps, practical problems, applying scientific knowledge to a solution, establishing practices, building things. So I guess you are, in terms of software engineering. And taking responsibility for them. Well, we'll look at that with reliability and dependability, actually. Soon, probably before lunch. No, after lunch, probably. So. In terms of professional responsibility, organizations that put trust in software developers, we'll talk about this a little bit towards, this doesn't happen towards the end. We'll talk about legal environment today, though. Competency, confidentiality, legal environment, that's actually kind of interesting. Acceptable use and misuse, and not only in terms of the practices, but also in terms of the end product and using other people's products and stuff like that. And we'll talk a little bit about, as well, open source and those types of issues. That's why I say it's kind of a special topics kind of class, because I'll jump over into 20 different subtopics associated with software engineering. It's not going to give you the same stuff as you've seen in Software Engineering 1, but it's going to kind of overlap with a lot of other information, hopefully, as well. Safety, quality assurance is safety as well. Safety is a big topic. What happens if the system fails? You're building software for a heart monitor, and the software fails. Not only do you have to consider the legal aspect of that, but what happens, are you going to build some sort of backup or something, some trigger, something happens if that software fails to make it dependable, and responsibility for testing, planning, things of that nature. And, in terms of the software development team, and we'll look at testing actually as well and quality assurance as subtopics, but who are you going to put in charge of that? And how are you going to get confirmation that the customer or the end user of that product is actually agreed to your specs and has provided you enough information so that you can actually build them what they want. The client responsibility, looking at the culture that expects the quality. We'll talk about that actually in Lecture 2. Qualified people, in terms of appointing suitable people for particular tasks and the role of that to meet the customer's needs. And a lot of it, again, is a business negotiation, a business communication kind of thing. Reviewing requirements and design, acceptability, time, incentives, stuff like that. So more topics in terms of the client relationship with the software development team. Computing management responsibility as well. Looking at the, again, let's look at the same slide. Well, it's the same issues, the culture, the qualified people processes. So it's more than just, software engineering is more than just following a methodology, coming up with deliverables, coming up with contracts, and putting it all together. So what we're looking at in this class is kind of a step above in terms of making sure that all that stuff actually works correctly. So we'll have to revisit some of the information, but hopefully take it a lot further. So testers, developers, those responsibilities. So in terms of what is engineering, in terms of how it applies to software engineering, second definition might be association with a professional who is licensed for professional society, perhaps might be an engineer, based on a set of educational program standards, knowledge, specified experience. So there's many different ways of actually putting a label on what software engineering is all about, or what engineering in general is all about. In most parts, it's a craft. And so why people study software engineering in general is to get better, to get a higher level of skills associated with the craft, which is why people go to art school. Say if they want to become a painter, they don't have to go to art school. But if they go to art school, they might actually learn some techniques, some things, and it might actually give them some ideas. So the purpose of this course is you might actually, already be an artist. You might already be a developer, and you come in and what you're going to expect out of it is going to be more like refinement. Oh, if you learn one thing, actually, it makes it worthwhile, essentially. In the long run, I mean, if an artist can learn one thing from going to paint school or whatever, it's worth it in the end, if you think about it. So it's a craft. Software engineering is just like going to art school, kind of, sort of. You're practicing. And the products are very varied. They're very, software engineering in general. Hopefully you're not going to be working on the same project over and over and over again throughout your entire career. Hopefully you'll be building different stuff. And client requirements can be very different. They can be very, a variety of different things. No standard process. So that's why we always have this controversy between, is it really engineering or is it is it development? Is software engineering really an engineering concept? Or, a lot of people don't think so. There's also new languages, new operating systems, new computing environments. So studying software engineering is not like learning a new language just because there's a new language out. So a lot of people actually think it is, though. A lot of people think, oh, I'm a software developer because I know Java. Okay, great. Now I learned JavaScript. Oh, okay, are you still a software engineer? So it's really a craft, actually. And here's where the craft, science, and engineering kind of comes together in terms of the big picture, where we have our craft, our production, our science, our commercial, professional engineering, all these kind of concepts working together, which is why I can kind of put it all together in terms of different subtopics. Like as an example, this is why you have software engineering programs that vary so much, actually, because some teachers or some schools focus on the algorithms, the data structures, all the technical related stuff, which is more the science area. Some focus on the commercial, the methodologies, which is really, and you see the center line here was actually kind of software engineering 1 in a lot of ways. Methodologies, looking at algorithms, how to actually implement a prototype, stuff like that. You could focus on compiler construction in terms of professional engineering, computer programming languages, stuff like that, operating systems, JVM, virtual machines and stuff like that. Or the business part of it, which is the production, the craft end of it. How do you put the pieces together? How do you perform? How do you create a working system? Kind of thing. So this class kind of surveys the entire realm of all the different pieces put together. And it works off of this basic philosophy, and this is the same one I give you in software engineering one, which is a fundamental assumption that good processes lead to good software, and that good processes reduce the risk, and good processes enhance visibility, and they make software more reliable, per se. So we won't look too much, but we will tap on this in the last interactive session, is the capability and maturity model. Some of you are probably familiar with this already. We'll look at standardization a little bit as well. And the goal of continuing to study software engineering and to take a class like this is to get yourself higher up the ladder. Get yourself at a higher level. Because what you want to do is have repeatable process. And each one of these CMM levels has a whole set of characteristics that are associated with being at that particular level. And it's great to be able to produce nice software, but it's nice to be able to repeat it, have well-known, repeatable processes that actually develop a methodology that works for your particular environment. So in terms of the initial stages, the initial one is you've got nothing. Then you start out with stage 1. Number 2, you can actually repeat your processes, hopefully. In terms of your planning, your scheduling, your tracking. And define, in fact, this is actually kind of the way the software engineering 1 and 2 kind of work together. 1 is kind of going through up to about stage 3. Software engineering 2 is covering management optimization, essentially. Assuming that you can produce software, assuming you know what a software methodology is, what a life cycle model, actually how to repeat, how to actually go through stuff. Well then, how do you, in terms of managing it, how do you manage the quality? And what kind of quantitative processes are you using? What kind of quality assessments? And this goes above and beyond the testing nature. And then continuously improving. How do you get past like the stagnant? Yes, we have a good level of everything. Well, how do you make that even better? How do you take it to the next level? If you can get to level 5, you're pretty good. So, and as the question on the bottom was the evidence that the CMM model actually reflects effective software development. That's actually a good point, because companies that are level 5 or whatever, they might go broke. There's no say that the economic changes or environment doesn't actually take the business out. So just because you make it to level 5 doesn't necessarily mean your company is going to be strong enough to survive the administration. So engineers, what's this say, Texas and the ACM? Well, American Computing Machinery. Hello. Good. How are you? So let's see. There's this proposal in the Texas legislation to license professional engineers in software engineering. That was a proposal. Actually, Texas is a pretty growing area. Some of you actually probably came from Texas to get here today. What role should the ACM play? That's actually kind of an interesting thing in terms of, if you think about other industries, going back to the whole engineering concept, we have licenses. You have to actually, like electrical engineers, and mechanical engineers, all different types of, you actually have to get certified and licensed in order to practice, and you actually have to, become a licensed blah, 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 blah. You don't have that for software engineering. So that's why you would get so much different variety of people and different variety of skill sets and practices that go on. It's one of the most unregulated official engineering, well, not really official, I guess, most unregulated industries around here, which kind of makes it interesting to look at in terms of what people are doing, which is how you get, like, cutting edge stuff that comes out. I mean, think about, like, all the Google development stuff. They have their own way of doing everything that's different than some other companies. So from the National Society of Professional Engineers, only a licensed engineer may prepare, sign, and seal, and submit engineering plans. Yeah, actually in other industries, as an example, you're an architect. You actually have to be, in order to get something signed off for building and planning departments and stuff like that, you actually have to go through a process. actually get, be certified. Licensures of individuals, federal, state, other things. So software engineering as an engineering topic, it's part craft, part evolving, it's part expertise, it's part cutting edge, it's part knowledge. So with the expertise is defined a formal body of knowledge. Whose expertise is a good question. Who's to say that that Apple has it all made? That they're doing everything. Well, we base it in this country. We base it off of profitability. We base everything off of that. So sometimes a software development company who's making a lot of money may not necessarily be the best, but they're good for some reason. And it's the market that's determining that. So, and what would be in an accreditation exam? Well, we don't have to worry about that. All right, so this is my the end of the fluff and puff of software engineering and why you want to study it, essentially, in terms of the overview of this course. And hopefully I've given you kind of an idea about some of the topics that we're going to be looking at, starting with Lecture 1. This really isn't Lecture 1. It's kind of the introduction to Lecture 1 that we're going to see. There's no assigned textbook for the course. It's probably giving you, hopefully, the understanding of why, because the topic variety is such varied topics, from business to software to testing to QA. It's really hard to actually put together a textbook for this type of course. But what I want to do now, because we're actually kind of into this about an hour so far, I want to take a short break. For those of you who just came in, I know some of you just walked into the door a second ago. Make sure to put your name on the rosters that are going around. There might be more than one sheet. Only put your name down once. I have had people in the past sign every one of the roster sheets. No, just put your name on one sheet that happens to be rolling around. And come up here and I can orient you to everything you've missed so far. What do you think about like a 10-minute break or something? Or 10 minutes, good, 10, 15 minutes. There's some coffee. You can go get some coffee at the second block. Go to the bathroom, settle in, come up here if you just walked into the door, and I can help you. You don't have to come up here if you already know what's going on. So, all right, see you in about 10 minutes, and we'll start Lecture 1.